Do you need a little more clarity on synthetic division versus long division? I'm going to take you back to grade 6 or 7, whenever it was that you learned long division, and we're going to apply it to polynomial functions. Plus, we're going to use the other method, synthetic division, to be able to divide our polynomial functions. There's a handout that I've created so you can follow along with this lesson and keep the notes for future reference. Hi, my name's Danielle, and I'm a high school math teacher and tutor for over 18 years. If you're new to the channel, I love releasing videos on how to learn math with strategy and mindset, so that way it could be easier for you. If you like this video or you're a high school math student, definitely hit subscribe down below. Okay, so you have that handout ready and printed? Let's dive in. So we are going to work through these questions live together. I haven't worked any of the numbers out ahead of time, so it is going to be my math brain live here with you. I think that's a great way to work as a math teacher because students are processing at the same time as me, and there's a lot to be learned like that. Okay, so the factor theorem. We're going to start with this because the factor theorem is a theorem that shows us we can factor down polynomial functions so that way we can actually graph them. And the way the factor theorem works, because in standard form, if you look at this polynomial function down here, there's no way I would be able to have enough information to graph it in standard form. So the factor theorem allows us to break it down into factored form. Now, what the rule says is if you have a factor, let's say x minus b, then what's going to be said about b is if you plug it into the polynomial, it'll produce a value of 0, meaning if y is 0, it's an x-intercept. Okay? So the same is true if you have ax minus b. If you isolate this, so set it equal to 0, you're going to bring the b over to the other side and divide by a. b over a will give you 0. If that's true, then you also have a factor, an x-intercept. So we're going to try and factor this with long division. Now, the key to long division is to start with this last value, the negative 24. And you want to test out all the values of negative 24. And this is going to be the tedious part. Okay, so it could be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6. Oh boy, plus or minus, what am I missing here? 8, and plus or minus, what am I missing? 12, yes, and plus or minus 24. I could literally try all of those. I'm hoping that one or two, positive 1 or 2, or negative 1 or 2 are going to work. So let's go to our calculator and literally punch in one of them. So if I were to punch in P of 1, what would I get? So I'm going to try doing 1 cubed on my calculator. I'm going to write the first one out for you so you know what I'm actually doing. 3 times 1 squared. You don't have to write this out every time. You just got to play with your calculator to find the one that produces 0 as an answer. 10 times 1 minus 24. So when you think about this, what's 1 cubed? It's just 1 plus 3 times 1, which is just 1, minus 10 minus 24. That's no good. It's going to equal 30. So I need to try another number. Maybe negative 1 would work. Okay, so I jumped a few steps here and I saw that P of negative 2 equals 0. Okay, and you can check that on your calculator as well. So I'm going to erase a little bit just because I need some space. Okay, and I'm just going to make note that P of negative 2 is equal to 0. So P of negative 2 is equal to 0. That means for long division, actually, what does that mean? That means that x plus 2 is a factor. So for long division, we're going to go x plus 2 on the outside of the house, the division house. And right now, I have x to the 3, x to the 2, x to the 1. And that's it, and 24. So I have all terms, none are missing. If x to the 2 was missing, I would put it in as 0x to the 2, okay? So x to the 3 plus 3x squared minus 10x minus 24, okay? And what we want to do now is we want to find, with the first term, what needs to be multiplied by here, or to x, in order to get x cubed, because we always want to subtract and get 0. So if you remember long division, you always have something on top that multiplies to the side and comes underneath to subtract. We are going to force it to subtract to 0. So that means I'm missing an x cubed. I'm going to put it on top of here. I'm going to line up the degrees that are the same. So what's x cubed times both of these? It's going to be x squared. I should be saying x squared. X squared times x is x cubed. X squared times 2 is positive 2x squared. I'm going to put a bracket around it and subtract. So I know that this subtract this is 0. I'm not even going to write it. That's what we wanted. And then 3x squared take away 2x squared is just x squared. Just like in grade 6 or 7, we're going to subtract. Maybe we learned this even earlier. The next term down, so it's minus 10x. What does the x have to multiply by to become x squared? A single x. So plus x, again, it's lining up above the degree that it matches. X times x is x squared. X times 2 is positive 2x. I'm just going to scroll down here. We are going to put this in brackets and subtract. And then we are going to get rid of this, eliminate the x squares. Negative 10 take away 2 is negative 12x. Let's drop down the negative 24 and keep going. What does the x have to become or get multiplied by to become negative 12x? We need a negative 12 up here. So negative 12 times x is going to be negative 12x. And then negative 12 times 2 is going to be negative 24. We're going to subtract. This becomes negative 12 plus 12, so 0, and negative 24 plus 24, which is 0 remainder. That's how we know we chose our factor properly or calculated it properly, because we should get a remainder of 0. What does this mean? This is telling us that our original function, p of x, can be written now with the factor x plus 2 on the outside and the quotient on top beside it, x squared plus x minus 12. And that just shows that if I were to re-expand the x plus 2 in, I would get the original cubic back. Now let's see if we can keep factoring. Does this break down? So let's make space. X plus 2 goes here. Okay, two numbers that multiply to negative 12 and add to x. I'm thinking 3 and 4. Let's play with this. Can I make this x plus 4, x minus 3? Yes, that would work, because 4x take away 3x would give me the middle term x, and 4 times negative 3 gives me negative 12. So there you have it. You have 3 factors. You've made something go from standard form, a polynomial function go from standard form up here to, factored form down here. Now, how do we do this with synthetic division? It's just another method, and we are going to do this with the same first step. So if I know that p of negative 2 is a factor, then I'm going to use this for synthetic division. So the way this is going to look, we are going to place the negative 2 on the outside, and I'm going to just give you a heads up. Certain textbooks will do it a little differently. They all work out the same way. The way I'm following is with the negative 2 on the outside of my little L chart. I'm going to place all these coefficients in my L chart. So 1, 3, negative 10, and negative 24. And I'm going to place a plus on the outside. So the first step is to drop the 1. From here, 1 times negative 2 is negative 2. So you're always going to take these bottom numbers and multiply them to this negative 2. Whatever the answer is, you're going to place under the next term. So 3 take away 2 is going to be positive 1. 1 times negative 2 is negative 2. Negative 10 minus 2 is negative 12. Negative 12 times negative 2 is negative 24. Positive 24. And then when I add these, I get 0 remainder. So what this means is p of x can be written with this x minus 2, x plus 2, because you always have to do the opposite when it's in factored form. And then you have, now this was a cubic. So this means this first coefficient is now squared. It's always 1 less than the degree you're starting with. So this is going to be x squared plus 1x for here minus 12. And if you notice, that is exactly what we got up here. And so we're just going to continue factoring like we did up above. This is going to break down to x plus 2, x, plus 4, and x minus 3. So your x-intercepts are negative 2 and 0, negative 4 and 0, and 3, 0. From there, we can definitely graph this. And there you have it. You can now use either long division or synthetic division to get your standard form polynomial function to factored form. And I think most students like synthetic division once they learn it, but unless your teacher specifies, you can use either method. Be sure to hit and subscribe down below, and I'll definitely keep making videos for you.